This is chapter 6.1 on polygons. The objective is to identify and classify polygons, and the second objective is to find the interior angles measures of a quadrilateral. The attributes of a polygon are they're formed by three or more segments. There are no curved parts. It is a closed figure, meaning that the segments meet at a vertex. Here are some examples of polygons. This example, you have a 1, 2, 3, 4, 5-sided figure. This is a pentagon. It is a closed figure. There are no curved sides, so it is a polygon. This is a triangle. It has closed sides, no curved lines, or no curved sides, so therefore that is also a polygon. These are not polygons. On this first figure, there's a curved portion, so it is not a polygon. On the second figure, it is not joined right here. It's not a closed figure, so it is not a polygon. And on the third figure, some of these sides are overlapping or intersecting with one another at more than one point. So this actually looks like two triangles, therefore it is not a polygon. The types of polygons, one of the things you'll be using for classification, comes from a table on page 304. There are sides and angles for these various polygons. Triangle, 3 sides and angles. Quadrilateral, 4 sides and angles. Pentagon, 5. Hexagon, 6. Heptagon, 7. Octagon, 8. Nonagon, 9. And decagon, 10. The suffix gon, which you see on many of these polygons, the suffix gon means angle or angles. Okay, this is checkpoint page 304. We're deciding whether the figure is a polygon. If so, we're going to tell what type. If not, we're going to explain why. In number 1, it is not a polygon because the figure is not closed. You can see there is a gap here between this segment and this segment. Number 2 is a polygon because it's a closed figure. All of the segments meet at vertices, and there are no curved sides. So since it is a polygon, you count the sides 1, 2, 3, 4, 5, which makes it a pentagon. Number 3 is also a polygon because it is closed. All of the segments meet at vertices, and there are no curved sides. It has 1, 2, 3, 4 sides, so it is a quadrilateral. Number 4 is not a polygon because it has this curved part. All right, quadrilateral interior angles theorem. If you take a quadrilateral and you divide it with a diagonal, so we'll just go ahead and draw a quadrilateral. So there's your quadrilateral. If you were to divide this quadrilateral with a diagonal goes from one non-consecutive vertice to another, you would see that it forms two triangles, and each of these triangles has a measure of 180 degrees. The interior angles of each of these triangles measure 180 degrees. Therefore, when you put 180 degrees together 2 times, you get 360 degrees, which is the measure of all the interior angles of any quadrilateral. Okay, this is the checkpoint from page 305. We're going to find the measure of angle A. In number 5, you have the quadrilateral ABCD. You can see the given angles. We add up the given angles, 110, 160, and we get 270 degrees. This is a mental math problem. To find the measure of angle A, we find the difference between those 3 angles and the missing and 360 degrees. So 360 degrees minus 270 degrees gives us 90 degrees. So the measure of angle A is 90 degrees. Okay, on number 6, you add up 160, 80, and 55, you get 295 degrees. You subtract that from 360 degrees at 65 degrees. So the measure of angle A, 65 degrees. On number 7, you add up 108, 108, and 72 degrees, which is 288 degrees. And then you go ahead and subtract that from 360 degrees, which is 72 degrees. So the measure of angle A is 72 degrees. Okay, now we're going to go on and do one last problem. It's going to be actually from the assignment on page 307. And so make sure that you continue the video. Okay, our final problem is number 18 on page 307, where we're going to find the value of x. You have these three angle measures given, and you know the unknown angle is x plus 30. So x plus 30 plus 80 plus 65 plus 110 equals 360. 360 being the entire measure of the quadrilateral's interior angles. 30, 80, 65, and 110 is 285. So x plus 285, we've just combined like terms, equals 360. Using the subtraction property of equality, we subtract 285 from both sides, and x equals 75 degrees. That's what's being asked for, but if you needed to find the missing angle right here, you'd add 30 to 75 degrees, and you would get the missing angle's measurement, which is 105 degrees. This now completes the Chapter 6.1 recording. If you've been absent, you're going to need to get the assignment from these notes, so you'll need to go continue on with the recording. We're going to go now to what the assignment is. The assignment, which will be done on the right side of your paper, you folded your paper in half vertically, is pages 306 to 307, 1 through 10, 15 through 17, 18 was done in the notes, 19 and 20.